So, once again, we have our two hosts, PC1 and PC2, and then we're going to do our translation on router 2. PC1, once again, has an IP of 10.10.10.1, if you see over here, and PC2 has an IP of 10.10.10.2. Now, we go to router 2, and we have to get rid of our previous NAT commands to be able to re-enter them in and do port address translation. Now, if you see, I already said no IP inside source list NAT pool CCNA, and I tried to take away the pool, no IP NAT pool CCNA, the first address 190.10.10.1 and the second last address 190.10.10.254, and it said pool CCNA in use cannot destroy. You actually have to first take away the no IP NAT inside source list NAT pool CCNA command before it'll let you take the IP NAT pool CCNA command. I got rid of both of them so we can continue with our lab. So now I'm going to recreate the pool, IP NAT pool CCNA. And now this time around though, I'm going to make my first address and my last address the same. So my pool has shrunk down to just the 190.10.10.1 address. The mask remains the same. And now I tie my pool to my access list as it was previously, my access list being called NAT, and my pool name being CCNA. So I will just copy and paste this command down here. IP NAT inside source list NAT pool CCNA. However, this time around, I will include the overload option at the end of this command. So I'm going to say overload. Hit enter. Let's check my work. Show or run. I have IP NAT outside on my outside interface, which is F00. I have IP NAT inside already from our previous configuration on our F0/1.10 interface. And then I have all my NAT commands here. So I have my pool, IP NAT pool CCNA, the pool being 190.10.10.1, and the last address also being 190.10.10.1 with a net mask of /24. Then I have my access list permitting my 10 network to be translated. And then I'm tying both of those commands together with the IP NAT inside source list, the list name being NAT, pool, the pool name being CCNA, but this time around with the keyword overload. Now I'm going to attempt to telnet from PC1 and PC2 to router 4, which is on the outside, and hopefully both PCs will be able to telnet to router 4 at the same time using the same address 190.10.10.1, and let's see how this works. Now, before I try and telnet to router 4, if you remember, let's see, I will show you. If I try to telnet to router 4, and if router 4 does not have telnet configured, it should not work. So telnet 150.101.45.4 being router 4's F00 address, and it's open. So at some point we had configured telnet on router 4. Well, this works. Let's go ahead and telnet from PC2 to router 4. And this also worked. So both PC2 and PC1 are telnetted right now to router 4 as visible by the prompt R4. And on PC1 also visible by the prompt R4. Let's go into router 2 and check our translation table. show IP NAT translations. And as you see, PC1 with an IP of 10.10.10.1 is going to the outside world with an IP address of 190.10.10.1, and PC2 also is going out with the same IP 190.10.10.1. Now, since I'm telnetting to the outside, I'm going to telnet users TCP port 23. So my destination port remains the same. However, if you notice, PC1 is using a different source port than PC2. So PC1, when it gets translated to a public address, uses a source port of 1025, which is the doing of router 2. Router 2 sends out traffic from PC1 with an IP of 190.10.10.1, but with a source TCP port of 1025. And router 2 sends out traffic from PC2 with the same IP, 190.10.10.1, but with a different source port. So the conversation separation is happening at layer 4. This is how router 2 keeps conversations going on between router 4 and PC1, separated from router 4 and PC2. This concludes the port address translation lecture. Next is static NAT.